In this video, we will learn how to solve a system of equations by elimination, and the type of systems of equations that we will talk about are linear equations in two variables. So let's start by answering this question: what is a system of equations? It is a set of equations that work together. And if all the equations in a system are linear, then it's called a system of linear equations. In this video, we will restrict ourselves to solving a system of linear equations in two variables, and the method we will use would be by elimination. Here's an example of what a system of linear equations in two variables looks like. So I have two equations in both the examples. Both of them are linear equations and both have only two variables. Now, what does it mean to solve a system of equations? It means to find a point or points that satisfy both equations. So the solution of a system of equations is a point or points that satisfy both equations. So let's take a look at this example. We have two equations, y is equal to 3x plus 2 and y is equal to negative 3x minus 4. And the solution to this set of equations is the point negative 1, because that point satisfies both equations. Let's see how is that so. So I'm going to take the first equation and I'm going to substitute x is equal to negative 1 in there. And then when I'm going to solve this, I get negative 3 plus 2, which is negative 1. So the point negative 1 satisfies the first equation. Now let's check the second equation as well. So I'm going to take the second equation and I'm going to substitute x is equal to negative 1 in there, and then I'm going to solve it. And what I get there is 3 minus 4, which is again negative 1. So what I see is when x is equal to negative 1, y is also equal to negative 1 in both the equations. So the point negative 1 satisfies both equations and therefore is the solution to this system of equations. There are three popular methods of solving systems of equations. Those three methods are solving by graphing, solving by substitution, and solving by elimination. So in this video, we will solve examples using solving by elimination method. So the third method here is the one that we will be using in examples in this video. So the question arises, what does it mean to solve a system of equations by elimination? Elimination means to reduce the number of variables in a system of equations. So as we try to solve equations, the first thing we will try to do is to reduce the number of variables in the system of equations. So here's a system of equations, and we'll solve this by elimination. And the first thing that I notice is that there's a plus 4y in the first equation and a minus 4y in the second equation. If I add plus 4y and minus 4y, I will get a 0. So what I'm going to do is I'm going to just add these two equations together. So x plus 5x gives me 6x, and the plus 4y minus 4y gives me a 0. So they get eliminated. And then 11 plus 7 gives me 18. So I have 6x is equal to 18, and that gives me x is equal to 3. Now what I can do with this x is equal to 3 is I can substitute it into either of those equations. So let's substitute in the first equation. So let's substitute x is equal to 3 in x plus 4y equals 11. So substitution means that I'm going to replace that x by 3 and solve for y. So subtract 3 from both sides. That gives me 4y is equal to 8, and that gives me 8 is equal to, y is equal to 2. So the solution to this system of equations is the point 3, 2. So here's my second equation, and I cannot directly eliminate any of the variables. However, in this first equation, I see a plus 8r. In the second equation, I see a minus 4r. So if I were to multiply this second equation, every term in the second equation by 2, I would actually get negative 8r, and then those can be added to eliminate. So let's rewrite the equation. So first equation I write just as I see it. There is no change. Second equation, I'm going to multiply every term by 2. So that gives me 4p minus 8r is equal to 10. and then I'm just going to add these two equations. So the negative 8r and the plus 8r, they give me a 0, and the 4p plus 4p gives me 8p, 11 plus 10 gives me 21, so I can see that p is equal to 21 over 8. Now I can take this value of p and substitute either into the first equation or the second equation, the original equations which were given. So I'm going to substitute it into 2p minus 4r. So substitute p is equal to 21 over 8 in 2p minus 4r is equal to 5. So 2 times 21 over 8 minus 4 over r is equal to 5. 42 over 8 minus 4r is equal to 5, and then I can subtract 42 over 8 from both sides. So subtract 42 over 8 from both sides. That gives me negative 4r is equal to negative 4, and that gives me r is equal to 1 over 16. So that gives me the solution to this set of equations is 21 over 8, 1 over 16, if I am writing the ordered pair as PR. Now again, here's another example. I cannot simply add the equations together to eliminate variables, but what I see is there's a 2x, the coefficient of x in the first term is 2, and the coefficient of x in the second equation is 5. If I were to multiply the first equation by 5 and the second equation by negative 2, then the coefficients of x in both the equations would become 10x and negative 10x, and those can be added to eliminate x. So I'm going to multiply every term in the first equation by 5. I'm going to multiply every term in the second equation by negative 2, and when I do that, I get 10x minus 30y is equal to negative 20. That's the first equation. And now the second equation becomes negative 10x plus 8y is equal to negative 46. And you can see that the coefficients of x now are 10 and negative 10. And if I just add these two equations, then 10x minus 10x gives me a 0. And here I would have a negative 22y is equal to negative 66. Dividing both sides by negative 22 gives me y is equal to 3. And now I can take y is equal to 3 and substitute into either the first original equation or the second original equation. So let's start solving the first equation. Let's substitute y is equal to 3 in 2x minus 6y is equal to negative 4. So 2x minus 6 times 3 is equal to negative 4, or 2x minus 18 is equal to negative 4. So that will then give me 2x is equal to 14, and that would give me x is equal to 7. So 7, 3 is the solution to this set of equations. Here's another system. Again, I cannot eliminate any of the variables directly. However, if I multiply the second equation by the opposite of the coefficient of x, which would be negative 2.5, then the second equation can be added to the first equation to eliminate x. So let's rewrite these equations. So the first equation I'm going to rewrite just as it is. There is no change. The second equation would become negative 2.5x minus y is equal to 12.5. So negative 2.5 times negative 5 gives me 12.5. And now I can add the two equations together. And when I do that, I find 2.5x minus 2.5x is 0. And then y minus y is also equal to 0. So on the left hand side I get a 0. On the right hand side of I get a 16.5. Now this is an impossibility. You cannot say that 0 is equal to 16.5. What that means for this system of equations is that there is no solution, and we say that this system of equations is inconsistent. So a system of equations that has no solution is called an inconsistent system. So I hope that you liked this video. If you liked it, please hit the like button and subscribe to our channel as well, so you will never miss a video. And if you would like us to make a video on a certain topic, email that topic to us and we'll make that video for you. If there's a problem that you would like us to solve for you and get a video solution, please email that problem to info@sageeducational.com. Again, I hope that you like this video.